Good morning, guys. Hope everyone has been well. This is Mr. Allen, and today is April the 30th, and we're going to continue comparing volumes. I hope everyone has been well. Now, I'm going to have 5 questions that I want to go through. Basically, we're going to be going through how you should be reading or perceiving each question. So I'm going to break down how we can go about like reading the question, understanding what it's asking, how to write down each step so that we know exactly how to break it down. And then afterwards, I'm going to have 4 questions in the description. I'm going to have the 5 questions we're about to do in the description, and then underneath 4 for you to do at home by yourself. But I just want to break them down with you. So if you go in the description and read with me, the first question should be, Tony used 1 centimeter cubes to build a bigger cube that had a volume of 27 cubic centimeters. Emilia used 1 centimeter cube to build a rectangular prism that has 4 centimeters long, 2 centimeters wide, and 2 centimeters tall. How does the volume of Tony's cube compare to the volume of Emilia's rectangular prism? So, looking at that, if we're trying to use but, the vocabulary word would be in the first sentence where it says volume of 27 cubic centimeters. So that makes us know we're using volume, and that the Tony's is a cube. If we underline the information, Emilia uses a cube, 1 centimeter cubes to build a rectangular prism. So we're comparing a cube and a rectangle. But the question says, we box in the questions, how does the volume of Tony's cube compare to the volume of Emilia's rectangle? So let's start writing stuff down. So if we were to write down Tony's cube, we can say that Tony, they gave us was 27 cubic centimeters, or cm3, while Emilia, they don't give us the volume, but they give us the dimension, and it's 4 length, 2 width, 4 height. So if we multiply that, 4 times 2 is 8, 8 times 4 is going to give us 32. So now Tony's volume is 27, Emilia's volume is 32. Now the question says, how does the volume of Tony's cube compare to the volume of Emilia's? The volume of Tony's cube is less than, greater than, or equal. So we can just look at Tony and Emilia. Is this number greater than, less than, or equal? Just by looking at them, we can see that Tony's is less than. So that's pretty much it for number 1. We're just going to find the volumes and then compare them. Number 2, a rectangular prism with a volume of 160 cubic centimeters is made out of 1 centimeter cubes. Which of these cannot be the dimension of the prism? So we know that the volume is 160. The formula for volume is length times width times height. They gave us 4 options that are three multiplications, or length times width times height. So we're just going to multiply each and see which one cannot be the dimension. So 5 times 4 is going to give us 20. 20 times 8, that's 160. We know that's not what we're looking for because that can be a dimension. 8 times 2 is 16. 16 times 10, 160 again. C, 4 times 2 is 8. 8 times 20 is 160. D, the only option left, is 6 times 5, which is 30. 30 times 4 is 120. We know that the answer is D because 120 cannot be the same as 160. So all we're looking for is which answer cannot give us the dimension 160 we're looking for. Number 3, Quinn is going to build a rectangular prism out of 96 1 centimeter cubes. She wants the height of the rectangular prism to be 4 centimeters, and she wants the width to be less than the length. How many rectangular prisms with different dimensions could she build? Now, these are one of those questions where I highly recommend just writing everything down and breaking it down. So what did they give us so far? They gave us 96, the volume. They did not give us the length or the width, but they gave us the height. So if we want to break this down, again, you want to have the letters by themselves away from the number. So we have length times width times 4. The way we'd get rid of the 4 is we'd just cross it out and then do the opposite of the operation. So we're multiplying by 4. The opposite of multiplying by 4 would be dividing by 4. So we have 96 divided by 4 is equal to length times width. What's 96 divided by 4? It's going to give us 24. So we know what length times width is equal to 24. We don't know what the length is, we don't know what the width is, but we know when you multiply them, you get 24. So how can I break that up to find out what the length and the width is? Well, we can use what we did previously in class, which is the lowest common multiple. What are all the numbers we can multiply to get to 24? So I like to start at the bottom, which is 1. 1 times what will give us 24? 1 times 24. So we have 1 and 24. We know could be a multiple or something we multiply to get 24. 2. 2 multiplied by what gives us 24? 2 times 12. So we know 1 and 24 is a combination. 2 and 12 is a combination. Let's keep going up. 3 times what can give us 24? We know 3 times 8 will give us 24. And then 4 times what will give us 24? 4 times 6. Now, the common rule with lowest common multiple is once you get to a number that you've already multiplied by, so we did 1, 2, we did 3, we did 4, 4 times 6. Now, 5 times nothing is going to give us 24, and we know 6 times 4 is going to give us 24. So once we actually get to that stage where we're repeating numbers, we stop. So we're going to stop at 6, and then we can just write them down. So we know 24 times 1, 12 times 2, 8 times 3, and 6 times 4. Is there anything else that can multiply to give us 24? No. Now, the key sentence here, it says, how many rectangular prisms with different dimensions could she build? And it says she wants the width to be less than the length. So all this is saying is that we can't use these numbers twice. So 24 times 1, let's say 24 would be the length. Yeah, because she wants the width to be less. So the length would be 24, the width would be 1. Can we use 1 times 24? No, because the width has to be smaller than length, so we can only use it once. So this is one set of length times width to give us 24. This is one option of length times width to give us 24. This is another option of length times width to give us 24. And this is another option of length times width to give us 24. So how many different options do we have to give us 24? 4. So to answer the question, how many rectangular prisms with different dimensions could she build? She can only build 4. Because there are only 4 options when you multiply to get 24, where one number is bigger than the other, or the length is bigger than the width. So it's a lot of steps or a lot of breaking down to do, but basically all you're doing is finding out the lowest common multiple for the number, and then seeing how many different sets you can have where one is greater than the other number. So number 4, Winston used 1-inch cubes to build a rectangular prism that is 4 inches long, 2 inches wide, and 8 inches tall. Linda uses 1-inch cubes to build a rectangular prism. It has twice the volume of Wilson's prism and has twice the length. Linda's prism has the same width as Wilson's prism. How tall was Linda's prism? Again, prism is just a 3-dimensional figure. So let's break that down. They gave us quite a few information. So with Winston, we know that the 4 was the length was 4, the width was 2, and the height was 8. Now with Linda, let's read this again. It says twice the volume of Winston. So when we multiply 4 times 2 is 8. 8 times 8 is going to give us 64. We know that Linda's is twice of 64. So 64 times 2, we know Linda's is 128 is the volume. Let's keep going. It says, and twice the length. So the length was 4, so we know that the length for Linda is 8. We know the volume is 128, the length is 8. What else do we have here? Linda's prism is the same, Linda's prism has the same width as Winston, so we know that the width is the same, the 2, and we're trying to find out what the height is. So, same as before, we're gonna write down the formula, and we're gonna say 8 times 2 is gonna give us 16, so we know 128 equals 16 times h. Before we have to get the letter on the side by itself, so what we do is we just cross it out, and we do the opposite of the operation on the other side. So 16 times h, the opposite of multiplying is dividing. So we have 128 divided by 16 is going to give us h. So 128 divided by 16, when you do the math, you're going to get 8. I'm going to find that the height is 8. Yeah, and that's pretty much it. Now, number 5. Emmy used 1 centimeter cube to build a larger cube. The edges of Emmy's cube is 3 centimeters. So when you see the word edges, all that means is all of the dimensions. So length, width, and height, they're going to be the same number, which is 3 centimeters long. So yeah, anytime you see edges, it just means the length, the width, and the height are the same number, which is 3 in this scenario. Tim has a cube-shaped box with edges that are 3 times as long as the edges of Emily's cube. How much larger is the volume of Tim's box than Emily's cube? So again, edges just means that the length, the width, and the height are the same, so which is 3. So Emily's is going to be 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we know the volume for Emily is 27. For Tim, they say that the edges are 3 times the length of Emily. So 3 times 3 is 9. So we know that the length is 9, the width is 9, and the height is 9. So when you multiply 9 times 9, we're going to get 81. When you multiply 81 times 9, you're going to get 729. Now, what is it asking us? It says, how much larger in volume is Tim's box than Emily's? So when you ask how much larger, it's you're comparing these two numbers. Same if I say, if you have 5 apples and I have 2 apples, what's the difference? Or how many more apples do you have? It's just asking us the difference. So what is the difference or subtraction between 729 and 27? It's going to give us 702. So yeah, it's a little bit of a wordy process, but I highly recommend writing down each step of what they give us and then going through each. Tomorrow, when you're going through comparing volumes, definitely make sure to come back to this video, write down each step. It's going to be the same format as these, and then pause it, rewind it, and so on and so forth. Now, below, you're going to have 4 questions. I highly recommend trying to go through them, pause the video, go back, see if you can break the steps down the same way I was breaking them down here. And yeah, we're going to pause the video and come back. All right, you guys did the right thing. Pause the video. We try to work the formulas out. All right, so number 1, it should say, start with Brandon is using 36 units, cubic centimeters to build a rectangular prism. He wants the height of the rectangular prism to be 2 units and wants the length to be shorter than the width. This is the same as before. Your answer should be 3. Yeah. Number 2, Kyle is using 24 unit cubes to build a rectangular prism. She wants the height of the rectangular prism to be 3 units, and she wants the length to be shorter. Same, you're going to be using lowest common denominator. You're going to find how many, it's going to be 24 divided by 3, and then you're going to find out how many different lowest common multiples you can have. Your answer should be 2. Lola is building a rectangular prism out of 81 centimeter cubes. She wants the height of the rectangular prism to be 4 centimeters. Which of these shows dimension Lola cannot use? Should be the first option. 10 times 8 by itself is 80. That's too big. So that answer is out. And then D. Kyle used 1 centimeter cubes to build a larger cube. The edges, which is 4 times 4 times 4, are 4. That should give you 64. Kyle is a cube-shaped box with edges that are 3 times as long as the edges of Steve. So that's going to be 12 times 12 times 12, which is going to give you 1,727. It says as long as the edges, how much larger is Steve's and Kyle? So again, you're comparing the two numbers. You're going to do 172 minus 64, which should give you 1,664. So yeah, again, 100% write down each step is really going to break it down for you. And if you have any questions, same as before, please show me what you've written down. If you're sending a request on Class Dojo, show me what you've written down in a picture, and then we can break it down together. That should be it for now. Thank you for your time, and I hope everyone's safe and having a great day.